if we are having a triangle ABC, so here small a opposite to vertices A, small a is this length of this side, small b is length of this side BC, small c is the length of the side AB. So if we need to find the area, we are having two formulas with us. First thing is area is equal to half into base into height. So if we are taking this BC as base, so height is from the other vertices. If we drop a perpendicular, if we drop a perpendicular from the other vertices, so the length of this perpendicular is called height. So half into base, so we can drop a perpendicular from this side also. So if we drop a perpendicular from this vertices, then we need to take CA as base. If CA is the base and this B, if we name this as E, so BE will be the height. So with this formula, half we can find the area of a triangle. To find the area of a triangle, we are having one more formula. This is called Heron's formula. Delta is equal to, so generally area is denoted by letter delta. So delta is equal to, area is equal to, this is square root is for the complete thing, square root of s into s minus a into s minus b into s minus c. Okay, where this s is called semi-perimeter. Semi-perimeter means sum of these three sides by 2. This is a, b, c, length of this a, b, c. So a plus b plus c by 2 gives semi-perimeter. This is the semi-perimeter. So delta is equal to s into s minus a into s minus b into s minus c and square root of. For equilateral triangle, if we take this ABC as an equilateral triangle, AD is the height. For equilateral triangle, all the three sides will be equal. So this is equal to A and C is also equal to A. For equilateral triangle, all the three sides are equal. So then this is called altitude. Altitude, or this is a perpendicular from point A, vertex A, to the other side. So this altitude is also called height. So it is directly, it is root 3 by 2A. So height of an equilateral triangle H is equal to root 3 by 2A. So you can use the same formula there. Area can be equal to delta. For equilateral triangle, area is equal to half into base. So base is this A only. Okay, BC is half into A into root 3 by 2A. If you multiply half into A into root 3 by 2, this is into, root 3 by 2A, you will root 3 by 4 A square. So area of an equilateral triangle is root 3 by 4 A square. You need to remember these formulas, whereas in exam point of view. And you also need to remember this height or altitude of an equilateral triangle. So H is equal to root 3 by 2A. This is very important. And these are two more important formulas for any triangle. So if you want to find circumradius, generally denoted by capital R, is equal to A into B into C by 4 delta. Whereas A, this is taken as capital A, B, C. Whereas small a, b, c are the sides. This is small a, small b, small c. So small a into small b into small c by 4 into delta. Delta you can calculate using Heron's formula or half into base into height. This is how you can calculate circumradius. And to calculate in radius, so in radius is directly delta by s. So delta is half into base into s, or Heron's formula, square root of s into s minus a into s minus b into s minus c divided by s. So s is, anyway you know this, semi-perimeter, a plus b plus c by 2. This is how you can calculate the in radius. But for an equilateral triangle, a is equal to b is equal to c, and you are also having formula for area. So you can substitute those values. So a into b into c, so all are a only, a cube by 4 into root 3 by 4 a square. I am cutting them. So it is a by root 3. For equilateral triangle, capital R is equal to a by root 3. You need to remember this for exam point of view. To find in radius, so delta is root 3 by 4 a square for equilateral triangle. Whereas s is equal to a plus b plus c by 2, we will get 3a by 2. So it is a by 2 root 3. This is a by root 3, this is a by 2 root 3. So for different triangles, so first let me take acute angle triangle. Acute angle triangle means the triangle for which all the angles are less than 90 degrees. So for this acute angle triangle, all the four, this circumcenter, incenter, centroid and orthocentre lies inside the triangle. Whereas if I take a right angle triangle, for right angle triangle, the circumcenter is at the midpoint of the hypotenuse. So this is the circumcenter. So you can draw a circle like this. And next, orthocentre is this right angle itself. So lay over the circumcenter and orthocentre. So you are having this incenter and centroid. These two, incenter and centroid, are always inside the circle, or always inside the triangle, sorry, whatever the triangle may be. Even if you take an obtuse angle triangle like this, obtuse angle triangle means one of the angle is greater than 90 degrees. So even for obtuse angle triangle, this incenter and centroid lies inside, and this circumcenter, if you take the circumcenter and orthocentre, both circumcenter and orthocentre lies outside the triangle. So incenter and centroid always lies inside the triangle, whereas circumcenter and orthocentre varies. Circumcenter is in the midpoint of the right hypotenuse, whereas it lies outside the triangle for obtuse angle triangle. For equilateral triangle, the three sides of a triangle are equal, then all these points will coincide. We'll have a single common point for whether it is circumcenter, incenter, centroid and orthocentre, we'll have a same point. For any non-equilateral triangle, apart from equilateral triangle, whether it's isosceles or scalene, any triangle, so this centroid, orthocentre and circumcenter, SGO, these three will be in the same line. Like if we draw a line S, if we draw a line intersecting S and O, then G also will be in the same line. Here also SGO will be same line. So you must leave this in center. Okay, SGO will be in the same line. Whereas for equilateral triangle, all the 4 points are the same.